Welcome back to Namielus MATLAB. Please don't forget to like our channel and then subscribe. This is a product of Namielus Educational, a subsidiary of Namielus Group Limited. You can call us on +256 779 358 445 or WhatsApp us on +254 73 805 446. In this session, we are looking at algebra, and our first subtopic is on introduction of algebraic tiles in algebra. We are going to study a graphical way of doing algebra whereby we don't have to do the usual calculations. The tasks which we shall work on will involve, but not limited to, 1. Representing of algebraic expressions using algebraic tiles. 2. Using algebraic tiles for operations on integers. The operations will be addition, subtraction, multiplication, and division. 3. Using algebraic tiles for operations on algebraic expressions. The operations shall be addition, subtraction, multiplication, and division. 4. Evaluation of algebraic expressions. 5. Solving linear equations. 6. Factorizing of polynomials. And 7. Solving quadratic equations. We shall be able to practically do all these and get solutions without necessarily carrying conventional calculations. This is a practical method, as we shall see. Algebraic tiles. These form the basic apparatus used to do algebra, normally made out of cardboard, plastic, wood, or any other materials easy to work with, such as manila paper and so on. When we say algebraic tiles, we have basically 3 tiles, as you can see. The 3 tiles, one is brown. We can have any other color, but for this session we are saying the first one is brown, the next is green, and the other is yellow. So the first brown has dimensions of x by x. That means it is a square tile. It is a square tile. It is x by x. Length and width are the same, but in an x dimension. Then the next tile, the green tile, has a dimension of x by 1. So in this, the length is x and the width is 1. That is the next tile. And then the final tile is having length 1 by 1. That means it is also a square. The tile 1 by 1 is a square. Then the tile x by 1 is a rectangle, and then the tile x by x is a square. So when we look at the area of this first tile, it will be x squared. When you look at it, it is x squared because it is x by x. Then the second tile, the green one, the area is x because it is x by 1, which is x. And then the final tile, which is 1 by 1, has an area which is 1. Now, when you look at each of the sides of these tiles, you will find a relationship between the green tile and the brown tile in terms of the sides. Then when you look at the yellow and the green tile, there will also be a relationship. Now we are going to see that this side, the x side of the green tile, is equivalent to either of the sides of the brown tile. That means this side can either fit here or fit there. Note that. Then when it comes to the yellow tile, it is 1 by 1. it can fit on only one side of the green tile. I repeat to emphasize this because it is a technique which will help us while we are building this in future. Now, we are saying one side of the green tile is x, and this x is equivalent to this side of the brown and then the other side of the brown tile. And when it comes to the yellow, yellow is 1 by 1. So the side of yellow is equivalent to this one side of the green. Now, for these tiles, this will be the face or the front face. So the front face will be colored brown, green, and yellow. We have 3 tiles, remember. But then the back face of these tiles is going to be painted or colored red. So this is the back face. The back face is negative. The front face is the positive side, and then the back face is the negative. So this tile will become a negative 2 squared, and then this tile will become a negative x, whereas this final tile will become a negative 1. So that is the representation of these tiles. These are 3 tiles with 2 sides. One side is positive, either brown, green, or yellow, and then the opposite face is, one face is positive, and then the opposite face is negative. The negative face is red. For those who wish to make their own tiles, follow the details below. So this is in terms of dimensions, whether you have a cardboard, whether you have wood, whether you have a paper. These are the dimensions we are taking. For x squared, we are taking the sides to be 10 by 10 centimeters. That is what we will use. For the x tile, we are taking 10 centimeters by 2.5 centimeters. And for the for the tile which is 1, the yellow tile, we are taking the dimensions to be 2.5 centimeters by 2.5 centimeters. So after you've made them in that dimensions, you can make many. For example, the 10 by 10, you can make 20 pieces or 10 pieces. Then the 10 by 2.5 or the X, you can make about 20 pieces. And then you can make 30 or 36 pieces of the 1 in order to do quite a number of items, as we shall see. Then make sure for the x squared, one side has its color. I mean the one face, the front face has its color. 2, the front face has its color for the x. And then 3, 1, the front color, the front face for the 1 has its own color. Then the opposite face, the back face, will be all red for all the tiles. Now, we are trying to represent the algebraic expressions here. That's what we are going to do next, to represent algebraic expressions using algebra tiles or algebraic tiles. So what we are going to do here, we have number 1, 3x plus 3. So we get our 3x here, and then we add 3. That is what we have for 3x plus 3. Now we come to number 2, x minus 1. So this is a single x. This is a single x. Then minus. Now the 1 is yellow, but the minus side of it is red. This is what we mean. So it will be 2x minus 2x minus 1. And then number 3, we have 2x. Those are the 2 of the x. And then we have 5. We have 5. Let's see, we have 5 ones, tiles of 1. So that is what we have. 2x and then plus 5. These are positive 1, 1, 1, making 5. Question number 4. We have x squared plus 2x minus 4. So the x squared is here. Then plus 2. These are the 2 positive. And then minus 4. These are the 4 which are minus. So the equation is, the expression is x squared plus 2x minus 4. And then let's go to number 5. It is 1, which is positive 1, minus positive 1 minus 4x. So these are the x squareds, but then there are 4 of them. So what we are doing, we are having this is 1 minus, it is red because it is the other opposite side. You flip it over when you are working. You flip it over and then get the negative side. So remember we said the tile had two sides, the positive and the negative faces, two faces. Now, number 6 is 3x. Number 6 is 3x. So 3x, this is what we have here for number 3, 3x, for number 3, 3x, and then minus 5, so we get 5, but then 5, but then they are negative, so we put them there, minus 5. They are negative, as we can see. 3x squared, this is positive, and then minus 5x, these are negative, and then plus 3 is a positive. So this is the representation for x. For number 6, where we have 3x squared minus 5 plus 3. Now, pause the video and then try activity 1.1. Number 1, 2x squared minus 3x plus 5. Work out those expressions, representing them using your tiles, and make sure everything is okay.